All right, the last example of the problem we're going to solve right now is a problem that involves more than one vertical force. So again, because there's more than one force, we're going to have to apply Newton's laws to build ourselves an equation. So we're going to start with an air conditioning unit which is being hoisted upwards by a cable. Okay, so maybe they're out there working on the field house. Who knows? Here is my air conditioner that I'm interested in, and there's a cable pulling upwards on it, and it's accelerating upwards. So I know there must be an upwards force on it due to the cable, and the forces that were exerted by cables are tension, so we call that F sub t. Now, because it is on Earth, there's a freebie. I always know gravity acts on it, and that's going to act downwards. But the force going downwards should be a little smaller than the force going upwards because we know it's accelerating upwards. So this is F sub g, the force of gravity. There are no other forces on it. The cable's pulling up, we got that. Gravity's pulling down, we got that. So let's make a variable list. We're going to have the force of tension in the cable. We're going to have the force of gravity pulling down. We're going to have the mass and the acceleration. So those are the four things we're going to have in this case. We know the mass is 400 kilograms. So we can put that in there. And we know it's accelerating upwards at 1.2. So that's going to be 1.20 meters per second squared. And that's all we are told in the problem, the mass and acceleration. Okay? So the first thing we are going to do, the first step, is to find the weight. And this is always the same. To find the weight, we just use the fact that the weight equals m times g. That's our first step. Okay? So we're not told the weight, we're not told the downwards force on the air conditioner, but we can always find it because it's always m times g. So in this case, the weight, F sub g, equals the mass, 400 kilograms, times 9.81 meters per second squared. So the weight equals, you can put that in your calculator. So I'm going to put 400 times 9.81, and that's 3,924. So 3,924 newtons is the weight. Okay? And that, of course, acts downwards. We have that in our diagram over here. Okay? All right. The second thing we're going to do is we're going to apply Newton's laws because we have more than one force in the vertical direction. So we're going to apply this principle, which says that the net force equals the mass times the acceleration. So for this problem, the net force is the forces that are going up. So that's going to be F sub t minus the forces that are going down, which is F sub g, and that net force equals m times a. So we now have an equation that we can use, and we are trying to find the force of the tension. Okay, so we are going to solve for the tension force. Okay, so to get the tension force by itself, we can just add F sub g to both sides, so that's pretty easy. So F sub t will be ma plus F of g. Okay, now it gets a little bit confusing. Is F of g positive or negative? Like, sometimes that's confusing. So when we're solving force problems, we're going to worry about the direction in our diagram. So I already took care of the fact that the force of gravity was going down, because right here I put a negative sign when I was finding the net force. So I've already taken care of the fact that it's down. I'm not going to double count that. Okay, so I'm just going to use the size of it here. Okay, so last step here is to plug in our numbers. So we have a mass of 400 kilograms times its acceleration, which is 1.2 meters per second squared, plus the force due to gravity, the weight. So that is going to be 3,924 newtons. And then, on my calculator, I'm going to take the 400 times 1.2 plus, and then if you have a calculator that stores your answers, you can just add your previous answer. So you don't need to type that back in again and risk making a mistake. So there we go, 4,404. So 4,404 newtons is the tension in the cable. I have I have three significant figures here. I have three significant figures here, so I'm going to keep three significant figures. So this is going to be 4,000. I'm going to keep the 4, 4, and the 0, and I'm going to truncate the 0. So we're going to have to write this like this. 4.40 times 10 to the third newtons is the tension in the cable. And I had to use scientific notation because I had to show that that 0 there was significant. Okay? So that's how we're going to solve the problems. When you have vertical problems, the first thing you got to do is find the weight, and that's always m times g. Once you know the weight, then use your free body diagram to build yourself an equation from the principle of Newton's laws, and then you can solve it. Okay, so you're going to solve a couple problems that involve vertical forces, one of which will always be weight.